In this video, we are going to learn about valence electrons and common ion charges. The highest energy electrons, which are the electrons in the outermost shell, are called the valence electrons. Electrons in completely filled shells closer to the nucleus are called core electrons. It is the valence electrons that are involved in bonding with other atoms. If we look at this model of an oxygen atom, the valence electrons are shown in red. Oxygen has a total of 8 electrons. 6 of these are valence electrons, and 2 are core electrons. We can determine the number of valence electrons using the electron configuration. The shell number with the highest value tells us which shell is the valence shell. The superscripts show how many electrons are in each subshell. For oxygen, the highest shell number is n is equal to 2, which includes the 2s and the 2p subshells. Adding the electrons together gives us 6 valence electrons, 2 in the 2s subshell and 4 in the 2p subshell. Now take a look at the magnesium atom, shown here. Magnesium has a total of 12 electrons. 2 of these electrons are valence electrons, and the remaining 10 electrons are core electrons. For magnesium, the valence electrons are located in the 3s subshell. Since there are 2 electrons in the 3s subshell, magnesium has 2 valence electrons. When atoms bond to other elements, they tend to gain or lose electrons in order to have 8 electrons in their outermost shell. This pattern is known as the octet rule. Metals tend to form cations by losing their valence electrons. For example, magnesium loses its 2 3s electrons, giving it the same electron configuration as neon. On the other hand, nonmetals tend to form anions by gaining electrons. Oxygen can gain 2 electrons so that it has 8 valence electrons just like neon. Once atoms form ions with noble gas electron configurations, they become less reactive. Noble gases already have 8 valence electrons, which is why they are generally unreactive. The number 8 comes from having 2 electrons in the s subshell and 6 electrons in the p subshell of the valence shell. On the periodic table, elements are arranged into vertical columns or groups, where elements share similar chemical properties. These similarities come from having similar valence electron configurations. All elements in group 1 have 1 valence electron. As a result, these elements, including hydrogen, tend to lose 1 valence electron when forming compounds, giving them a +1 charge. Elements in group 2 tend to lose 2 electrons, allowing them to achieve the same electron configuration as the noble gas that comes before them. Moving over to the nonmetals, these elements are closer to the noble gas by gaining electrons. Electrons in group 17, the halogens, are 1 electron away from noble gas electron configuration. So they tend to gain 1 electron to form 1- ions. Elements in group 2 tend to gain 2 electrons, forming 2- ions, while elements in group 15 tend to gain 3 electrons, forming 3- ions. Some metals near the transition metals also form predictable ion charges. These elements form a triangle on the periodic table with corners at silver, aluminum, and indium. In this triangle, Group 11 elements, such as silver, commonly form +1 ions. Group 12 elements commonly form +2 ions. And group 13 elements commonly form +3 ions. Notice how the number of elements in that column matches the charge of the ion. Remember that metals tend to form cations, which have positive charges, and nonmetals tend to form anions, which have negative charges.